Hello everyone, this is my first video on my YouTube channel. So on this YouTube channel I will be doing IGCSE related stuff. So if you're interested, make sure to like and subscribe so you wouldn't miss upcoming content. So today I will be doing IGCSE physics topic question. So this topic is about motion and I will be doing every type of questions related to motion. So let's start with the first one. So the first question starts with a ball rolls down a ramp and onto a horizontal surface. Let's underline this. The first section of the horizontal surface is smooth. The second section of the horizontal surface is rough. So the first section is smooth and the second one is rough. So this brings a change in speed. Figure 1.1 shows a speed time graph of the ball. So this is the figure. So the speed increases until time around 12 point something, and then it stays constant for a while, and then it decreases again. So let's go to the first question. So state the time when the ball reaches the start of the rough section. So when the ball reaches the start of the rough section of the horizontal surface. So how we can determine which part is the rough section is, okay, so on a rough section there is more friction, so the speed is going to be decreasing. So we just have to identify the point where the speed starts decreasing. So on the graph, that point is right over here. So this is a point where the speed starts decreasing. So now we just have to find the time. So we can go down to the x-axis. So we can go down the x-axis. Sorry about the wacky line. So the time is going to be around here. So now we just have to figure out what this represents. So 20 boxes represent 1 second. So this is half a second, which is going to be 2.5. So to determine this is almost half. So this is going to be 2.2. So the time is going to be 2.2 seconds. Sorry about my handwriting. Okay, the next question, explain how figure 1.1 shows that there is no resultant force. There is no resultant force on the ball when it rolls along the smooth section of the horizontal surface. So if there is no resultant force, that means the speed will not change. So if the object is at rest, it remains at rest. And if the object is moving in a constant speed, that means the object will continue moving in a constant speed. So there will not be a change in speed or direction. So on the graph, if there is no resultant force, that means the line is going to be horizontal. So we're talking about this section over here. This section in bold. So this is a section where there is no resultant force because it's horizontal, so that means the speed is not going to be changing. So our question asks that, explain how figure 1.1 shows that there is no resultant force on the ball when it rolls along smooth section. So one of the explanations could be the line is horizontal, so that's going to be one of our answers. It's horizontal. So the next answer is going to be there is no acceleration, because if the line is horizontal, that means that the speed is going to be constant, so acceleration is going to be 0. So we can say there is no acceleration. So let's move on to the next one. So C, using Fig 1.1, determine the acceleration of the ball as it rolls down the ramp. So to figure out the acceleration, we go back to the figure. So we're asked the acceleration as it rolls down the ramp. So that means when it had increasing speed. So when you go back to the graph, we are asked to determine the acceleration of this section of the graph. So to determine the acceleration, what we have to do is we just have to pick 2 points. We have to pick 2 points from the graph. Let me just read this to make it clearer. So we just have to pick 2 points. So to make it easier, we could pick this point over here and also this point. So now we just have to determine we have to find the slope or the gradient of the line. So to do that, the formula for slope is y2 minus y1 over x2 minus x1. That's the formula. So what we're going to have is, so the y of this point is going to be 12. 12 minus, and over here is going to be 6 over, so now we have to find the x coordinates of the line. So this one is going to go down over here. So this is a point. So this is 0.5. This point over here. So that means this is going to be so each box represents 0.05. So it's 1, 2, 3, 4 boxes. So the answer is going to be 0.7. So over here is going to be 0.7. So this 0.7 represents x1, which is relating to the 6 on the y-axis. So the next one, to find the next one, we can go down. This is the point. So from 1, it's 1, 2, 3, 4, 5, 6, 7, 8. So we can do 8 times 0.05 plus 1. That's going to be 1.4. So it's going to be 1.4 minus 0.7. So it's minus 0.7. So 12 minus 6 is 6 over, so 1.4 minus 0.7 is 0.7. So 6 minus 6 divided by 0.7 is going to be 8.57. We can round that one to 8.5. So we can round that to 8.6. So the answer is going to be 8.6. So this is the final answer. So the answer is going to be 8.6, and the unit for acceleration is meters per second squared. So it's going to be meters per second squared. We can move on to the next one. The ball starts from rest at the top of the ramp. Show that the ramp is 9.6 meters. So on this question, we are told to prove that the length of the ramp is 9.6. So that means we have to find the distance traveled by the ball. To find the distance, what we're going to do is, so on the question that we're told the ball starts from rest at the top of the ramp. So that means the ramp, okay, so from the top of the ramp to the bottom of the ramp, the graph is going to go straight diagonally. So on the graph, this section is what we're talking about, this diagonal section which is straight. This is the one we're talking about. So to find the distance, so the distance is the same as the area under that section. So we have to find the distance, the area of this triangle over here, this right angle triangle. So let me erase this line to make it clear. So to find the area of a right angle triangle, the formula is area is equals to half base times height. So the area is half base times height. So the heights, we have the point over here, and then that point is going to be 12.8. So okay, so 10 bucks represents two units. So this, the fourth one, two, three, the fourth one is going to represent 12.8. So the height is going to be 12.8, and the base is going to be right in between 1 second and 2 seconds. So it's going to be 1.5. So the base is 1.5. So area is going to be half times 1.5 times 12.8. So that's going to total to 9.6 meters. So here we have the proof. So they told us to prove that it's 9.6, and then if we use this method, we're going to be getting 9.6. So that's just 2 marks over there. So we can move on to the next question. A car of mass m is traveling along a straight horizontal road at a constant speed v. At time t equals to 0, the driver of the car sees an obstruction in the road ahead of the car and applies the brakes. The car does not begin to decelerate at t equals to 0. Explain what is meant by deceleration. So to define deceleration is basically acceleration, but then with decreasing speed. So what we can write is okay, it's the rate of change of velocity. That's going to get us 1 mark. And then to get the other mark, we can write with decreasing speed. With decreasing speed. So that's how we define deceleration. The rate of change of velocity with decreasing speed. The next one asks, suggest one reason why the car does not begin to decelerate at time equals 0. So for that one of the reasons could be, okay, so at time equals 0, the driver sees an obstruction. So at time 0, if the driver sees an obstruction, so the driver's reaction time might be slow. That means there's going to be a delay between seeing the obstruction and applying the brakes. So that could be one reason. So what we could write is there could be a delay between seeing the car and applying the brakes. And applying brakes. So that's going to be our answer. So we can move on to the next question. figure 1.1 is the distance time graph for the car from t equals to 0. So from t equals to 0, it's going to be curving, and then the slope of the curve is going to be decreasing. So let's go to I state the property of the distance time graph that corresponds to speed. So what this question is asking us is, from the distance time graph, what is the speed? So to find the speed, we just have to find the slope or the gradient. So we can just write slope. So we can just write slope or gradient. Slope, or we can write gradient. That's going to be our answer. So the next one, use fig 1.1 to determine the initial speed of the car. So to determine the initial speed of the car, what we do is first we have to have the initial distance. So initial speed of the car means like the speed of the car at the beginning of the time. So to determine the speed, we can take coordinates from this area, and then we can find the gradient using the formula y2 minus y1 over x2 minus x1. So one of our points could be over here, 0, 0. So one of them is going to be 0, 0. That's one of the coordinates. And then for the second one, we can pick this point. So this point could approximately be, the x-coordinate of the point is going to be 1, 2, 3, 4, 5. It's going to be 0.5. So the coordinate is going to be 0.5, comma. And then when you go down, when you go to this across to the y-axis, it's going to be 1, 2, 3, 4, 5, 6. But then not exactly 6. So if 10 boxes represent 20, that means half of it's going to represent 10. So over here it's going to be 10 meters. Distance is going to be 10 meters over here. And then if we go up like 1, it's going to be 11 or 12. Let's take 11. So we're going to be 11 minus 0. So 11 minus 0 over 0.5 minus 0. So it's basically 11 over 0.5, and that's going to be 22. So our answer is going to be 22 meters per second. So the initial speed of the car is going to be 22 meters per second. On the next question, when the car is decelerating, there is a constant resistive force F on the car due to the brakes. The deceleration of the car is greater than F over m, and it's not constant. So from this statement given, we know that the deceleration of the car is greater than F over m. So F over m represents acceleration. So the formula for force is going to be force is equals to mass times acceleration. So if we rearrange this formula to find acceleration, the formula is going to be acceleration is equals to force over mass. So this statement is telling us that deceleration of the car is greater than the acceleration, and it's not constant. So the deceleration is greater than the acceleration, and the deceleration is not constant. So when you come to I, the deceleration of the car is, okay, explain why the deceleration of the car is greater than F over m, which is equivalent to the acceleration. So there could be many reasons for this. One of them could be air resistance. So because of air resistance, it's opposing the motion of the car. So that means the acceleration is going to be decreasing. So the deceleration is going to be greater than the acceleration. So the answer could be air resistance. Air resistance. Or another answer could also be friction force, because the friction also opposes the motion of the car. So it increases the deceleration, but the acceleration is going to be decreasing. So it can be friction force. Let's move on to the next one. Explain why the deceleration is not constant. So this is a 2 marks question, so we have to provide 2 answers. So one of the answers is going to be, the deceleration is not constant because the air resistance is going to be decreasing, or the resistive force is going to be decreasing. So let me explain how. So if a car is moving and at a certain speed, and if an air resistance is acting upon the car, the speed of the car decreases. So if the speed of the car decreases, that means the air resistance is also going to decrease. So with the speed of the car decreasing, the air resistance is going to be decreasing. So the deceleration is not constant. So because one of the reasons is going to be air resistance is going to be decreasing too. Air resistance decreases. And the next one is going to be the speed of the car decreases. So, okay, because air resistance is acting upon the car, the speed of the car is also going to decrease. So that other answer could be speed of the car decreases. So these are going to be our 2 answers. Let's move on to the next question. An airplane accelerates along a horizontal runway before takeoff. The airplane accelerates for 35 seconds. The speed of the airplane when it takes off is 72 meters per second. Figure 1.1 shows the speed of the airplane varies between time t equals 0 and time t equals 35. So the first question asks us, define acceleration. So acceleration is basically the rate of change of velocity. So acceleration is the rate of change of velocity. That's going to get us our 1 mark. The next one, BI, calculate the average acceleration of the airplane between time equals 0 and time equals 35. So on this question, we're asked the average acceleration. So this is a speed time graph. So to find the acceleration, you just have to find the gradient of this line. And then since we're asked the average acceleration, that means we can take the point from where it can be the curved line or the straight line. So to make it easiest, we can take this point and this point. So it's going to be 72 minus 0, which is 72, over 35 minus 0, which is going to be 35. So 72 divided by 35 is going to be 2.057. We can round it to 2.06. So the acceleration is going to be 2.06. This is 1 more question, so relatively it's easy. When we move on to the next one, the combined mass of the airplane, its passengers and its fuel on takeoff is 1.1 times 10 to the power of kilograms. So we're given the mass, but it's in standard form. So what I like to do is first change it into decimal like decimal form. So 1.1 times 10 to the power 5 is basically 100, 1,000. So it's going to be 1.1, and then it's going to be 4 zeros. So 110,000. This is going to be the mass. And calculate the average resultant force between time t0 and t35. So force, to find force, the formula is force equals mass times acceleration. So we're given the mass and we have found the acceleration. So the force is going to be 110,000 times 2.06. So which is going to be 226,600. But we can just round it to 230,000 because we can round it to two significant figures. $230,000. That's going to be our answer. And then the unit for force is going to be newtons. The next question, the force provided by the engines of the airplane is constant. Give one possible explanation for the change in acceleration of the airplane between t0 and t equals 35 seconds. So one of the reasons could be air resistance or the change in air resistance, because if the air resistance decreases, that means the speed of the plane is going to be increasing. But if the air resistance increases, the speed of the plane decreases. So either way, the air resistance affects the speed, which also affects the acceleration. So our answer could be change in air resistance. So answer is going to be change in air resistance. Change in air resistance. So on the next one, on figure 1.2, sketch the graph to show how the acceleration of the aircraft varies between t equals 0 and t equals 35. So we can go to the previous graph and then we can see that we're given the speed time graph and then we're told to graph the acceleration time graph, and it's 3 marks. So to graph the acceleration time graph, we have 3 sections to this graph because we're having 3 marks. So we need to look at the previous graph to graph the acceleration time graph. So firstly, we have this straight line, a steep straight line up to here. So this represents a constant acceleration because the slope is going to be the same. So in an acceleration time graph, the constant acceleration is presented by horizontal line. So first we draw a horizontal line. This presents, sorry. We have to draw a horizontal line. So this represents the first section of the graph, which is a steep slope on the speed time graph. So now we have to draw this curved section. So this curved section. So this curved section of the graph represents decreasing acceleration. So if the graph is going to be like this, that means the slope is going to be decreasing. But if the graph is going to be like this, that means the slope is increasing. So in this case, the slope is decreasing. So if the slope is going to be decreasing, that means the acceleration is going to be decreasing too. So we're going to present the decreasing acceleration by a straight line going downwards. So this is the second section of the graph. And then when you go up, the change of this becomes a straight line again. So if it's a straight line, that means it's going to be a constant acceleration. So we're going to draw another horizontal line to represent constant acceleration. So this is a final graph. So 3 sections to the graph and 3 marks to the question. So this is how we graph the acceleration time graphs based on velocity time graphs. Let's move on to the next question. A skydiver of mass 76 kg is falling vertically in still air at time t equals 0. The skydiver opens his parachute. Figure 1.1 is the speed time graph for the skydiver from t equals to 0. So we have the speed time graph, and so the speed is going to be decreasing, and then after a while it's going to be constant speed. So if the graph is going down like this, that means the acceleration of the graph is increasing. So the first question, using figure 1.1, determine the deceleration of the skydiver immediately after the parachute opens. So immediately after the parachute opens is right over here, before the first second or so. So we just need, so to find deceleration, we just have to find the slope. So we can just pick 2 points. So let's pick this point. And the next point could be this one. So the y-axis, the y-coordinate of this point is going to be, so 10 boxes represent 20 units. So that means 5 boxes is going to represent 10 units. So it's going to be 42, 44, 46, 48, 50, 52, 54. So this is going to be 54. And for this one, it's going to be 40. And the x coordinate, we can go down. And this is going to represent 0.1. And when we go down for our next coordinate, this is going to represent 0.1, 2, 3, 4, 5. This is going to be 0.5. So our coordinates are 0.5, 40, 40, and 0.1, 54. These are 2 coordinates. So to find the gradient, we said that is going to be y2 minus y1 over x2 minus x1. So it's going to be 54 minus 40 minus 40 over 0.1 minus 0.5. 0.5. So 54 minus 40, that's 14 over 0.1 minus 0.5 is going to be negative 0.4. So when we divide that, it's going to be negative 35. So the acceleration is going to be negative 35. But then we're asked to find the deceleration. So if the acceleration is negative 35, to find the deceleration, it's the same as negative acceleration. So we can just write 35 over here. So if we're asked to find the deceleration, we can write it as a positive number. But then if we were asked to find the acceleration, that means we should write the negative to show it's decelerating. Let's move on to the next. The force due to air resistance acting on the skydiver immediately after the parachute opens. So to find the force, what we do is formula force equals to mass times acceleration. So we are given the mass, which is going to be 76 kgs. And then we've also found out the acceleration is going to be 35. So the mass is going to be 76 times 35. We could use that formula. So 76 times 35 is going to be 2,660 newtons. So we can move on to the next question. Explain in terms of forces acting on the skydiver his motion between T0 and T6. So we have to use the forces acting on the skydiver. So from times 0 to times 6. So we're asked to explain this curve by using the forces acting on the body. The question has 3 marks, so we should mention 3 points. So the first one is going to be the object is decelerating. So at that point, the air resistance is higher than the weight. So we can write in the first moment, the air resistance is going to be higher than the weight. So the air resistance is higher than the weight or the downward force. And then our next point is going to be on the second section of the graph. We can see that on this section, we can see that the curve is decreasing. That means the deceleration is decreasing. So this is because as air resistance acts on the body, that means the speed of the body is going to decrease. So while the speed is decreasing, the air resistance is going to be decreasing too. So the second point could be as the air resistance decreases, the speed also decreases. And then for the last one, the last section of the graph is a straight horizontal line. Straight horizontal line. So that means there is no resultant force. So the weight of the object acting downwards is equal to the air resistance. That's why the object is moving at a constant speed. So we can write there's no resultant force as our third point. No resultant force. So these are our 3 points. On the next question, explain why opening the parachute cannot reduce the speed of the skydiver to 0. So this is a straightforward question, and there's 2 points, so that means we should write 2 answers or 2 explanations. So if the speed of the skydiver is 0, that means there is no air resistance, and then that's impossible. So one of the explanations could be if the speed is 0, that means the air resistance is going to be 0 too. If speed is 0, air resistance is going to be 0 too. So the next point is going to be the forces are going to balance greater than 0. So this means that, okay, so if the forces balance greater than 0, that means the object it's not gonna have any change in speed anymore. So the second point is gonna be the forces balance in speed greater than zero. So that means, let's say the force balances at speed 20 meters per second. So if the force is balanced, that means the speed is going to stay constant. So there won't be any change in speed. So the speed of the skydiver cannot decrease to zero. Then this is our last question. So figure 1.1 shows a sealed weather balloon which is stationary in still air. State whether the overall density of the balloon is and its instrument is greater than, less than, or the same as the density of the surrounding air. So on this question, we are told it's stationary in still air. That means it's not moving up or it's not moving down. That means the density is going to be the same as the density of surrounding air. So density is going to be the same. So density is going to be same. So the next question, at night, the gas inside the balloon cools. The pressure of the air outside the balloon remains the same. State whether the balloon rises, falls, or remains stationary. So we are told in the question, the gas inside the balloon cools at night. So if the gas cools, that means the particle move less. So the pressure inside the balloon is going to decrease. So let's say this is a balloon, and then there are different gas particles. So if the gas inside the balloon cools, so if the temperature decreases, that means the gas particles are going to move less. So the volume is going to decrease. So if this was at day, that means the balloon at night is going to be something like this. The gas particles are going to be closer to each other, so they're not going to move that much. So the volume is going to decrease. So the pressure of the outside air, the air outside the balloon remains the same. So if the pressure outside remains the same, so the balloon is going to fall. So the balloon is going to fall. Because when the volume decreases, so this question is talking all about density. So we know that density is equals to mass over volume. So we know that at night the volume decreases. So if the volume decreases, that means the density is going to increase. So the higher the density, that means it's going to be heavier. So it's going to go down and it's going to fall. So the next question asks to explain your answer. So in the explanation, we can write the volume decreases as I've shown over here. So the volume decreases, and the second one could be the density increases. So since volume is inversely proportional to density, that means if volume increases, density decreases. So they're opposite. So when volume decreases, the density is going to increase. So density increases. C. An object from the balloon. An object is released from the balloon. It starts at rest and eventually reaches constant speed. On the axis, sketch the speed time graph to show this motion. So an object is released from the balloon and it starts at rest. So our graph is going to start from 0, 0 and eventually reaches a constant speed. So a constant speed is represented by a horizontal line. So that means at the end of the graph somewhere, we're going to be having a horizontal line. So the graph is going to start from the origin, and then it's going to eventually reach a constant speed. So that means it's going to be a smooth graph, and then it's going to be horizontal at the end. Something like this. So it's going to be something like this. The next one, state the values of the initial acceleration and the final acceleration of the object. So the initial acceleration, so we don't have any values on this graph. So how we can know the initial acceleration is, we all know that on Earth the acceleration of every object is going to be 10 meters per second squared. So we're going to write that. So the acceleration is going to be 10 meters per second squared, because any falling object has an acceleration of 10 meters, approximately 10 meters per second squared in Earth. And the final acceleration, so we know that this is a horizontal line. So when there's in a speed time graph, if the line is horizontal, that means the acceleration is going to be 0. So the final acceleration is 0. Yeah, so that was the final question. If you enjoyed the video, make sure to like and subscribe for more upcoming content. Thank you.